standard deviation. It says what we're going to look at are 15 pairs of graphs, and the mean for each graph, mu, is given. So, since it says the mean is mu, are we dealing with a population or a sample? Population. For each pair of the graphs below, indicate whether one of the graphs has a larger standard deviation than the other, or if the two graphs have the same standard deviation. Try to identify characteristics of the graph that make the standard deviation larger or smaller. You can check your answers against my key as you work. All right, so what we're going to do is first we're going to take our graph and we're going to draw in our means, and we're just going to kind of eyeball it. If the mean is right here on this one, 2.57, so I'm going to draw it somewhere around there, and then 3.33 on this one, so somewhere around there, can I tell which one it looks like has more data closer to that mean? What do you think? Just eyeballing it. You think A has the data closer to the mean, so it would have the smaller one. Is that what we think just by eyeballing it? A is smaller. And guess what? We are correct. So what would we circle over here? Because this didn't say smaller, this says larger. But now let's actually mathematically find an estimate for the standard deviation and compare the two. Now, this looks somewhat like a histogram. And we have the information, we have the frequencies here. And these are our scores. On the histogram, I told you earlier, we had that column on our chart called midpoint. And I said sometimes you're given the graph and you have to go back and find the data, and we would use the midpoint. So this is one of those cases. So if I was going to take this graph and find the standard deviation of the data, what I would do is use the midpoint of each of these intervals. What is the midpoint from 0 to 1? 0.5. So these are my midpoints, and then beside that I'm going to put the frequency. And what is the frequency of that one? 2. What is the midpoint of the next interval? 1.5. And what is the frequency? 3. Midpoint of the next? 2.5. Frequency? 4. Midpoint? Frequency? 6. And then 4.5 with 5. And then 5.5 with 1. So what we could do is enter this data into our calculator. Put this in L1, put this in L2, and whichever calculator you're using, use this as our data. This is the frequency of each piece of data. And find the standard deviation using your one variable statistics. And we know we're looking at the standard deviation of the population because we were given mu as our average. Okay, did we get a standard deviation of approximately 1.365? Okay, any questions? All right, you try to find the standard deviation of B all by yourself.
S of X again?
The sample standard deviation?
And then the other one is population.
Population. Okay, did you get 1.491?
Yes.
All right. So sometimes we got it right to start with, but sometimes you may need to actually calculate, find an estimate of the calculations of those. Is that it? Nope. Looks like I've closed it. Standard deviations. All right. The ones I would like you to calculate on your packet, and you can circle these. Number 3, I'd actually like you to calculate them. Number 4. Number 7. Number 9. And number 11. So that was 3, 4, 7, 9, and 11. Now, if you need to calculate it for any of the others, feel free to do so, because you don't have to. If you could just draw and look at it. You may work together, you may work in groups, and you have the remainder of class, and you're to finish for homework. Okay?
What did you get for the standard deviation second graph?